Star-delta transformation. In complex networks, the three circuit elements, that is resistance, inductance and capacitance, are connected in two ways. One is star connection and another one is delta connection. Star connection looks like this, whereas delta connection looks like this. As they look as a star, they are known as star connection. As they look as a delta, they are known as delta connection. And star connection is also known as a Y connection and T connection. Similarly, delta connection is also known as pi connection, as they look as a pi. To solve this complex networks, we need transformation of star network into delta network as well as delta network into star network. Then we need the relation between the elements of star and delta. Consider this star network having the resistances RA, RB, RC. If you observe from this side, RAB is equals to RA plus RB. Here RBC equals to RB plus RC. Now here RCA equals to RC plus RA. In delta connection, that RAB equals to, now the resistances R1, R2, R3. So R1 is in parallel with R2 plus R3. Then R1 multiplied by R2 plus R3 divided by R1 plus R2 plus R3 from this side. From this side, RBC equals to R3 is in parallel with R1 plus R2. Now this will be equals to R3 R1 plus R2 divided by R1 plus R2 plus R3. Similarly, if you see from this side, then RAC equal to R2 R1 plus R3 divided by R1 plus R2 plus R3. This is the resistance between the terminals A and B, and this is the resistance between the terminal A and B. Now, equating both of them, we'll be getting RA plus RB equals to R1 of R2 plus R3 divided by R1 plus R2 plus R3. Similarly, RBC, RB plus RC equals to RBC here, that is R3 R1 plus R2 divided by R1 plus R2 plus R3. RCA equals to RC plus RA, which equals to R2 of R1 plus R3 divided by R1 plus R2 plus R3. Now we got three equations, 1 and 2 and 3. Subtract the equation 2 from 1 and third equation. We'll be getting RA plus RB minus RB minus RC plus RC plus RA. RB, RB, RC, RC. Then 2 RA equals to right hand side R1 plus R2 plus R3. R1 R2 plus R1 R3 minus R3 R1 minus R3 R2 plus R2 R1 plus R2 R3. R3 R2 R3 R1 R3 R3 R1. 2 R1 R2 divided by R1 plus R2 plus R3. 2 RA. RA equals to R1 R2 divided by R1 plus R2 plus R3. Similarly, equation number 2 minus equation number 3 plus equation 1, then you will be getting RB equals to R1 R3 divided by R1 plus R2 plus R3, and B minus 1 plus 2. RC equals to R2 R3 divided by R1 plus R2 plus R3. Now we got the resistances of star network in terms of resistances of delta network. Now we need to find the resistances in terms of star network. So for that, RA, RB plus RB, RC plus RC, RA equals to RA, RB, that is R1 square, R2, R3 divided by R1 plus R2 plus R3 whole square plus, when you multiply these two, R1, R2, R3 square divided by R1 plus R2 plus R3 whole square plus, when you multiply these two, R1, R2 square, R3 divided by R1, R2 plus R3 whole square. Now for this, LCM is R1 plus R2 plus R3 whole square. R1, R2, R3 are common. We will be getting R1 plus R2 plus R3. So squares gets cancelled. Then we are getting RA, RB plus RB, RC plus RC, RA equals to R1, R2, R3 divided by R1 plus R2 plus R3. Now dividing on both sides with RA, here also we have RA, then this will be RB plus RB, RC by RA plus RC, which equals to R1, R2, R3 divided by R1 plus R2 plus R3. RA is nothing but this one. This is R1, R2, R1 plus R2 plus R3. Now we are going to get R3 equals to RB plus RC plus RB, RC by RA. Here what we have done, dividing on both sides with RA, and here substituting the value of RA, we got R3. Similarly, dividing on both sides with RB, we are going to get R2 equals to RA plus RC plus RA-RC divided by RA. Similarly, divide with RC, you are going to get R1 equals to RA plus RB plus RA, RB divided by RC. Now, these are the resistances of star connection in terms of delta resistances. These are the resistances of delta connection in terms of star connections. By using these formulas, we can transfer a star network into a delta network as well as delta network into a star network. The simplest way to remember these equations, if the star network is given and we need to find out the delta network elements, then R1 equals to RA plus RB plus RA, RB divided by the remaining resistance RC. R3 equals to RB plus RC plus RB, RC divided by the remaining is RA. R2 equals to connected resistances RA plus RC plus RA-RC divided by the remaining resistance RB. If delta is given and we need to find out the star networks, RA equals to the two connected resistances R1, R2 divided by the total resistance, that is R1 plus R2 plus R3. RB equals to the two adjacent resistances, that is R1, R3 divided by total resistance R1, R2 and R3. RC equals to the adjacent resistances, that is R2, R3 divided by total resistance R1 plus R2 plus R3. If RA equals to RB equals to RC equals to R, that means the star network resistances are equal, then R1 is equals to R plus R square by R, or 3R. Then R2 equals to 3R. R3 equals to 3R. Similarly, if R1 equals to R2 equals to R3 equals to R, that is, all the resistance in delta network are equal to R, then the star network resistances, that is RA, equals to R into R divided by R plus R, which is nothing but R squared by 3R. It's nothing but 1 by 3 times of R, and RB equals to 1 by 3 times of R. RC equals to 1 by 3 times of R. By generalizing, resistance of Y network is equals to 1 by 3 times of resistance of delta network. Here, by generalizing, you can write resistance of delta network equals to 3 times of resistance of Y network.